We all know that we need energy to do work. Our energy is our capacity to do work. Where do we get this energy from? We get the energy to do work by eating healthy food. Go to the next screen to analyze some objects and find out what type of energy they possess. When the girl leaves the trolley moves because of the energy produced by the girl. When the boy stops pedaling the cycle moves ahead because of the energy produced by the pedaling action of the boy. When the pendulum is released, it swings because of the energy produced by the motion of the pendulum. When the person plays the guitar strings vibrate because of the energy produced by the person striking them. Let us derive a formula to help us calculate the kinetic energy of a moving object. First, we need a moving object. The car will do nicely. Let us assume its mass to be m. Let its current velocity be u. The car accelerates. Let its new velocity be v. We know that the relationship between the initial and final velocities in relation with the acceleration and displacement is v square minus u square equals 2a into s, where a is the acceleration of the car and s is the displacement. We can now rearrange this equation to get an expression for displacement s. Let us remember this as equation 1. Let the force produced to bring about the change in acceleration and the subsequent displacement be F. We know the force used to produce the acceleration A in the car of mass m is F equals m into A. Let us remember this as equation 2. Now, we have learnt that the moving car has a capacity to do work. Work done by the car to produce displacement S by force F is W equals F into S, which is also the kinetic energy possessed by the car. Now, let us use equations 1 and 2 and replace the variables in the equation for the increase in kinetic energy. How will the equation change if the car is starting to move from a stationary position? Since the car is stationary at the start, its initial velocity will be 0. Thus, the equation changes to half m into v square. Since kinetic energy is dependent on motion, it changes if the velocity of the object changes. From this equation, it becomes clear that if the velocity doubles, kinetic energy will increase fourfold. Note that velocity is squared in the equation for kinetic energy. From the equation, it is clear that if mass increases, the kinetic energy of the object also increases proportionately. What are the units of mass and velocity? Mass is expressed in kilograms and velocity is expressed in meters per second square. The SI unit of kinetic energy is thus kilogram meter squared per second squared. It is also called a joule. In CGS systems, unit of kinetic energy is erg. Energy possessed by an object owing to its motion is known as kinetic energy. The kinetic energy of an object can be found using the following formula. Kinetic energy is expressed in joule. The energy gained by an object by virtue of its motion is called kinetic energy.